Hey you guys, this is Mr. Sal. We're going to look at the Pythagorean Theorem again, just in a different way. So thanks for watching. Don't forget to like, comment, and subscribe. These problems are just a review of stuff we've done already. So you should have been able to do these. So number one, I'm going to expand both of these, which means that I would have 2a's multiplied, and then I would have 6a's multiplied together. And then I just need to see how many total a's I have multiplied together, and that's 8 of them. Number two, I'd have 7 b's in the numerator and 3 in the denominator. On this one, this set of b's and this set of b's and that set of b's are going to cancel out, which means overall I've got some b's left, 4 of them specifically. Alright, on number 3, I'm going to distribute this 4 into the exponents of the parentheses. And the d has an exponent of 1. So we've got these 3 bases. C has a power of 3 times 4, which is 12. D has a power of 1 times 4, which is 4. And E has a power of 2 times 4, which is 8. On number 4, this is a negative exponent, which means it may be better to see this as a fraction, because the negative exponent tells us we're going to flip the fraction and change the exponent to a positive. And finally, number 5, anything to the power of 0 is 1, and that's it. This is on the cover page of the packet. State standards. This is the standard we're looking at in this lesson 13 stuff. 8G7, so it's geometry, that's what the G is. Apply the Pythagorean Theorem to determine unknown side lengths in right triangles in real world and mathematical problems in 2 and 3 dimensions. Here's the objective for lesson 13. I can find the lengths of sides of right triangles in 2 dimensions. Take a moment and write that down. Determine the length of side C in each of the triangles below. So this is 1A. Before we start on this one though, are we solving for a hypotenuse or a leg on this one? This one's the hypotenuse. Take a minute and solve this one with your neighbor. Alright, let's do this one together then. On this one, we could use the Pythagorean Theorem on this one. Actually, let's do that. So I know I've got a leg squared, and I'm going to have to add the other leg squared. And then this will equal the hypotenuse squared. So on this one, we already know we're solving for the hypotenuse, which is opposite, the side that's opposite to the 90-degree angle, which is just labeled as C. So I've got this leg, which is at 12. And this other leg, which is at 5. So evaluating these, 12 to the power of 2 is 144, and 5 to the power of 2 is 25. So when I add these together, I should get my hypotenuse squared. And when that happens, 144 plus 25 is 169, and this equals the hypotenuse squared. Now that's if I made a square out of that hypotenuse, then it would have that area 169. But what I really want there is the side length of that square, which means I would take that area and square root it. Now when I put this in the calculator, square root of 169, I get 13, which is the answer we want. If the calculator gives us a decimal, then we just want that square root for now. Later on we'll learn how to simplify those, but for now I can see that the length of the hypotenuse is 13. Alright, this is 1B. It still says determine the length of side C in each of this triangle, so it's another triangle. Take a moment on 1B, 1 minute, and do this with your neighbor. On this one, we'll do this one a little different. Since we used the Pythagorean Theorem on the last one, we'll use the squares, which is still the Pythagorean Theorem, on this one. So, what I'm going to do then, is I'm going to take this leg, and I'm going to make a square out of it. And the area of that square would be 0.5 times 0.5. or 0.5 squared, which is 0.25. Then I'm going to take this other leg, and I'm going to make a square out of it. And I can find its area by taking 1.2 and squaring it, which would be 1.44. Now the hypotenuse, if I were to make a square out of it, I would just take the red area, which is 0.25, and add it to the purple area, which is 1.44. And when I add these two together, I get the area of the green square, which is at 1.69. So if I wanted just the length of that hypotenuse right there, I'm going to take the area, 1.69, and square root it. Now when I put that in the calculator, I get 1.3. So our answer on this one is 1.3. So our problem solving strategy for this week and last week is to read the problem, so that helps us to understand it. So number 2, determine the length of side B in each of the triangles below. So we got this example A and then example B. Take 1 minute and do this one with your partner. Since it's the first one on part B, there's more examples. We'll use the squares on this one. So this side length B, or line segment CA, is that a leg or a hypotenuse?
Leg.
That's correct, it is a leg. So if I make this a square, and then I have this other leg, and I make a square out of it, and then I've got this hypotenuse, and I make a square out of it, then the purple square plus the red square will give us the area of the green one. And the purple square, I know its area, 4 times 4, which is 16. And the green square, its area, is 5 times 5, which is 25. So if I want the area of the red square, I've got to take the hypotenuse square, which is 25, and the purple square, which is the leg square, 16, and I need to subtract these. Now when I do that, it gives me the area of the red square, but I don't want the area, I want the side length. So to get that side length, I just take the area and square root it, and that would be 3. This is part B on number 2. Take 1 minute and do this with your neighbor. Go! So on this one, I'm going to use the Pythagorean Theorem again, which means I'm going to take one leg and square it and add the other leg squared. And this will give me the hypotenuse squared. So just to identify the different parts on this, I've got this leg, and I know it's a leg because it makes up that 90-degree angle that side does. So one of the legs is 0.4. This would be our other leg, which is unknown right now, is B. And then this side, which is opposite to that right angle, is the hypotenuse at 0.5. So just evaluating 0.4 squared and 0.5 squared, I get 0.16 and 0.25. And the rest of that stays the same. So now, this goes back to 7th grade stuff. To solve this equation, I need to subtract 0.16 from both sides. This is called a principle of equality. And when I do, I get b squared equals 0.09, which would be the area of that leg as a square. But we don't want the area, we just want the side length. So I'm going to take that area, 0.09, and square root it. When you put this in the calculator, it gives you 0.3. So the length of side length B is 0.3. Again, we're working on our problem solving strategy of reading the problem so that we can understand it. Number 3, determine the length of side line segment QS. Take 1 minute and do that with your partner. determine the length of QS. What we really have here is two triangles, but we may also notice on this that this is a straight angle right there, and since this angle is 90 degrees, we get to know that this angle also is 90 degrees. The reason why this is important is because it's not just one triangle that we have right here, it's really two right triangles that have been pushed together. So if we look at these separately, then we can find the two distances individually in order to find the full length of it. Okay, so what I'm going to do is I'm going to take this triangle QTR and I'm just going to move it down here so that I can find that length separately on this, okay? But let's label the vertices. Alright, so I have this triangle now. And the side lengths are labeled, which means all I really need to do is find the length of this leg right here. And I know it's a leg because it's one of the side lengths that makes up this 90-degree angle in green. So I know I'm going to have to take one of the legs squared and add it to the other leg squared. And then it should equal the hypotenuse squared. So this side length right here at 15, that is a leg because it makes up that right angle. So I've got 15 squared. And then I've got the hypotenuse over here, which was given to us at 17 squared. And I know that's the hypotenuse because it's opposite that right angle. But then I have that side length, QT, which I'm going to just say is the side length B squared. Alright, then we'll square these. So 15 to the power of 2 is 225. 17 to the power of 2, what is that, 289? And then this would be added to the leg squared to equal 289. So if I wanted to find out the value of B squared, or that side length as a square, then what I'm going to need to do is subtract 225 from both sides. And then this equals now, B squared equals, thank you, 64. But I don't want the square of B, I just want B. So I'm going to take that B. The area of that square would be 64. I'm going to square root it to find the side length. And if I put that in the calculator, it tells me that its length is 8. So if this length is 8, then this portion of QS is 8 as well. So what I need to do now is look at this other triangle. Here, we'll see if I can get this one to work. So this triangle here, which is a separate triangle, I need to move over here. And I'll label the parts that I know on this. Alright, so in this right triangle, I need to find this missing length, TS. So I'll use the Pythagorean Theorem again. I have a leg squared plus the other leg squared should equal the hypotenuse squared. Now the leg that I have right here, TS, I know that's a leg because it makes up that right angle. So I'm going to say that's my unknown. The other leg right here is 15. So the hypotenuse is 25. Now if I square those, I can find these values. 15 to the power of 2 is 225, which we've seen already. And 25 to the power of 2 is 625. So now I've got a squared plus 225 equals 625. So then to solve for a squared, I'm going to need to subtract 225 from both sides of this equation. And then I've got a squared equals, looks like it's 400. But I don't want the square of a, I just want the a value. So I'm going to take that area of 400 and square root it. Which if I put in the calculator, it tells me it's 20. So that means that the length of TS is 20. Which means this length right here is 20. So if I want the full length of this, I've got to take the 8 plus 20, and I get a length of 28. I can find the lengths of sides of right triangles in 2 dimensions. We just did plenty of that. Well, let's look at some more examples. So in this problem set, number 1, now again our problem solving strategy is to read the problem so that we can understand it. Determine the length of side C in each of the triangles below. Well, this kind of comes to a fork in the road. Do you guys want me to use the squares or just the Pythagorean theorem? Alright, so let's use the Pythagorean theorem on this one. I'm going to take one of the legs and square it and add the other leg squared, and this will be the hypotenuse squared. So I can see this side length is a leg because it makes up that right angle at 6. And then this side also is a leg because it makes up that right angle at 8. And the hypotenuse is the side opposite to that right angle at C for now. So evaluating this, 6 to the power of 2 is 36. 8 to the power of 2 is 64. So when I add those together, I should get the hypotenuse squared. And 36 plus 64 is 100. And this equals the hypotenuse squared. But I don't want the hypotenuse squared. I just want the hypotenuse. So I'll take the area, square root it, and then I see that the square root of 100 in my calculator is 10. So the length of this hypotenuse is 10. Alright, since we used the Pythagorean theorem on that last one, we'll use the square method on this one, which is still the Pythagorean theorem. But we'll look at this side length, which is a leg because it makes up that right angle. And I'll show it as a square. And the area of that square is going to be 0.6 squared, which would be 0.36 the area. And then this other leg, if I drew it as a square, something like this, then the area would be 0.8 squared, which would give me an area of 0.64. Then we have this hypotenuse, which is the side opposite to the 90-degree angle. That's an OK square. That'll do. Its area is going to be the area of the red square, 0.36. And I'm going to add the area of the purple square at 0.64. When I add these two together, I get 1.00. But I don't want the area of that. I want the side length. So if the area is 1, then I take the square root of 1, which is a side length of 1. So I'm going to show this one using the square stuff, which means I'm going to draw the squares on this triangle. 2A, determine the length of side A in each of the triangles below. Alright. So on this one, I'll need a little bit more space though. Alright, on this one, I'm going to draw a square here from that leg. Then I've got this leg. Also, I'm going to draw this square. And then we have the hypotenuse, which I'm also going to draw a square for. Now I know the red square plus the purple square will give me the area of the green square. So if I wanted the area of the green square, which we can find, because we have the side length, 17 times 17 is 289. And then the red square, I know its side length, so I can find its area also. 8 times 8 would be 64 square units. So this purple square, since I would need to add the purple square to the red square to get the green one, if I want the area of the purple one, I'm going to take the green square area and subtract the red square area. So the green one was at 289. The red one's at 64. So I'm going to subtract these to get the area of the purple square, which would be at 225. Now if that's our area, and we want the side length, which is what we do want, then I'm going to take that area at 225, and I'm going to square root it. When I put that in the calculator, it gives me the length of 15. So that would be my final answer on this one. Alright, we used the square method on that last one for 2. So 2b, we're going to use the Pythagorean theorem here. And again, we're just going to identify the different parts of this right triangle. This is a leg because it makes up that right angle, and this is a leg also because it makes up that right angle. So I'm going to take the two legs and square them, then I'll add those two, and it should give me the hypotenuse, which is the side opposite to that 90-degree angle. It's there in green, and I'm going to square that as well. So I've got that first side at 0.8, that's a leg. The other side is the A, which is a leg, and the hypotenuse is at 1.7. So I'm just going to evaluate these squares. 0.8 to the power of 2 is 0.64, and 1.7 to the power of 2 is 2.89. So adding that a squared, I get that 2.89. So 0.64 plus a squared equals 2.89. I'm going to solve this equation by subtracting 0.64 from both sides of the equation. Then I get a squared equals 2.25, which would be the area of the square if I made a square out of that purple side length. So I'm just going to take that area, 2.25, and square root it to find the length of that side. And that actually simplifies even further into 1.5. So the length of A is 1.5. (3a) Determine the length of side B in this triangle below. So on this one, we'll use the Pythagorean theorem again. So I'm going to take one of the side lengths, or the leg squared, and add that to the other leg squared. And it should give me the hypotenuse squared. So I can see that A, we'll see, or this leg is 20. And then this is also a leg, which is just shown as B. And then I have this hypotenuse at 25. So I need to solve for that missing leg value. 20 squared is 400, and 25 squared is 625. So I'm going to add that to B squared, and that'll equal 625. So to figure out B squared, I'm going to have to subtract 400 from both sides. Then I get B squared equals 225. And then finally, to solve for this one, I'll square root the area, which will give me the side length B at 225. The area, square rooted, is the side length. But if I put that in the calculator, it comes out as a whole value 15. So the answer we want on this one is 15. Alright, 3b, determine the length of side B in each of the triangles below. So we use the Pythagorean theorem on that last one. We'll use the squares on this one, even though the Pythagorean theorem would give us the same answer. So once again, we'll just identify this B value here. That's a leg value, and we're looking for first the area of that square, and once we find the area, we can find the side length of the square. So I've got this red square, which is also part of that leg. Its area is 2 to the power of 2, which is 4. And then I've got the hypotenuse over here. And I'll draw its square, which has an area of 2.5 to the power of 2, which is 6.25. So the area of this purple one is going to be the area of the hypotenuse square, 6.25, and we're going to have to subtract the area of the red square, which would be 2.25. Now that's the area of the purple square. So to find the length of that, I'm going to take the area, the side length of that square, 2.25. I'm going to take that area and square root it, and then it comes out as 1.5. For A, determine the length of side A in each of the triangles below. Alright, we'll use the Pythagorean theorem on this one. So I'm going to take one of the legs squared and add the other leg squared. and that will give me the hypotenuse squared. So just identifying these, I have this side length A, which is a leg, because it makes up that right angle. And I've got this side length 12, which is also a leg, because it makes up that right angle. And that should equal the hypotenuse, which in this case is 20, because it's opposite to that 90-degree angle, and that sets up the Pythagorean theorem. So if I evaluate these, 12 to the power of 2 is 144, 20 to the power of 2 is 400, and the rest of it stays the same. So now to solve this one, I'm going to have to isolate the a squared, so I've got to subtract that 144, just using principles of equality on this one. And that gives me a squared equals 256. But that's the area of that square. What I really want then is the side length a. So I'm going to take that area, 256, and square root it. And if I plug that in the calculator, it comes out as an even 16 on that. Alright, so for B, we'll use the squares on this. And again, we're looking for first the area of this square, which will then help us to find the side length of that square. And to do that, we've got to look at the other two squares. Now this is a leg right here at 1.2. So its area is 1.2 to the power of 2, which is 1.44. Next up would be the hypotenuse as a square. So I'll draw this as a square. Its area is its side length to the power of 2, which is 4. So the area of that red square, which is a leg square, we're going to take the area of the hypotenuse as a square, and we're going to subtract the area of the other leg as a square. And when we do that, it looks like we get 2.56. So that's the area of this red square, but we want the side length. So I'm going to take that 2.56, and that will be the side length, and square root it, which turns out to be 1.6. And that would be our final answer for this one. All right, number 5. What did you notice in each of the pairs of problems in 1 through 4? How might what you notice be helpful in solving problems like these? Take a moment to write a couple sentences on this. I'll give you guys a minute, and then we'll show you something that you should have written. All right, so you should have had something written like this, right here. In each pair of problems, the problems and solutions were similar. For example, in problem 1, part A, showed the sides of the triangle were 6, 8, and 10. And in part B, they were 0.6, 0.8, and 1. The side lengths in part B were a tenth of the value of the lengths in part A. The same could be said for parts A and B of problems 2 through 4. This might be helpful for solving problems in the future. If I'm given side lengths that are decimals, then I could multiply them by a factor of 10 to make whole numbers, which are easier to work with. Also, if I know common numbers that satisfy the Pythagorean theorem, like side lengths 3, 4, and 5, then I recognize them more easily in their forms, in their decimal forms. That is 0.3, 0.4, and 0.5. So, these are called Pythagorean triples. We can scale those up or down, and as long as we have that relationship, we can kind of manipulate the values to be something easier to work with. So that's the objectives for lesson 13 there. I can find the lengths of sides of right triangles in 2 dimensions, which is what we were just doing all the time in that lesson, and that's finding either leg values, missing leg values, or missing hypotenuse values for those right triangles.